All right. Okay. So these are the radios that I have home brewed. So upper left corner is my novice transmitter, which of course I don't have anymore. But that was a 6A G7 1625 homebrew radio. That's it there, and then there's the power supply there, which is also homebrew. And the receiver was a Lafayette KT200, so that's gone. And I'll talk about the rest of these radios in the pages that follow. But there was this radio in the late 60s, early 70s, and then everything else has been 21st century. Now, with the exception of these radios here and this radio here, everything is here in the back corner. So all of these radios here are in the back corner, and we've actually been operating them the last day or so. So my first single sideband transmitter started out as a phasing rig, and it was a 4-band transmitter with a single 6146, and used the B&W phase shift network. When I got promoted to first lieutenant, I had enough bucks to go buy a filter and the crystals, so I converted it to a filter rig. And it was based on that radio you see on the left called Filter Type 100 watt output sidebander. And that was in one of the ARRL single sideband books, and I've never really seen too much about it since then. It uses 12 tubes, and it has 7360s for the VFO balance modulator, the carrier oscillator and balance modulator. That's one tube, and then it uses another one for a heterodyne mixer. The 9 megahertz crystal was from a company called Excelsior Springs Electronics Labs, which I think was in Kansas City. You probably never heard of them. Anybody ever heard of them? I didn't think so. All right, so it became apparent pretty quickly that I was in over my head with this radio. But when I built it, I was in my early 20s, and it never occurred to me I couldn't make it work. Well, at the time, all I had was a Heathkit VTVM and an RF probe, because that's all the ARRL books ever said. Peak this circuit till you get maximum RF voltage. No scope, no two-tone oscillator, nothing. The chassis wasn't deep enough for a band switcher. If you look at right there, that's the band switch. Everything's kind of smashed together because it's just not deep enough. So that was a lesson that I learned. If you're going to make a band switcher, don't work yourself into tight corners. I found the 7360 circuits to be pretty troublesome, although I've done some work to it recently, and I found out I was getting a lot better sideband suppression than I thought, because at the time I made this, I didn't know how you measured sideband suppression. So it really is about 60 dB, but I have always found balance modulator circuits to be very mysterious and very difficult to deal with. It actually does work. I used to put it on the vintage, the 20 meter net a long time ago, but it's still got some issues, like almost no output on 15 meters for reasons I've never been able to understand. But anyway, at this point, I'm probably not going to do anything else to it, because it's a piece of my history, and why change it? So that was built from about 68 to 74, and then I didn't do anything else for a long time. So when I decided to go back to homebrewing in this century, around 2009, I came up with the idea of this radio here. I had done some experimenting with solid-state phase shift networks and audio filters. So and how am I going to do this? How am I going to build it? At the time, I was pretty cheap, and I started looking at the price of rack panels and chassis, and I said, geez, that costs more than everything else in the whole radio. So I thought, well, and then I saw some junk ARC-V transmitters, and I thought, hey, why don't I just make a transmitter along the lines of the famous Cheap and Easy by Tony Vitale, and I'll keep the 1625s, but I'll put fabulous phasing circuitry into it. So And then later, I built a matching receiver on another junk Arc 5 that I had because I had scored a McCoy crystal filter at a Hamfest for $10 with 2 sets of crystals. So I thought, well, maybe I could make them transceive, and indeed they do. They have the VFO comes through on one BNC on each, and the carrier comes through on the other one. So they transceive quite well. Now this phase shift network, this is actually the phase shift network here. That's that 60 dB job that's been in the ARRL handbooks, a polyphase network or whatever they call it, with 60 dB of suppression. So I cobbled that together on a perf board, and then I dripped epoxy all over them because I found out that as I worked with it, I kept bending the caps back and forth and handling it, so I figured I better glue them together. I'm going to break one off. In front of that is a 8-pole Butterworth low-pass filter and high-pass filter in series. So the bandpass is 300 to 2500 hertz by design at 6 dB. And it is, by God, right on the money. And I designed that using TI software that you could get freeware out there using op amps. And then these 4 boards, this is like a power supply board, and this is the audio output board. You mash them all together and put them in a mini box. So that's the top of the radio. There's that phase shift network, 1625s, PA capacitor and loading capacitor. I think it's a driver. I keep the same Arc 5 VFO components, the range set capacitor, the coil, and then the big capacitor underneath. And the rear capacitor is actually better because it has a preload adjustment on the back, and you could take all the backlash out of that worm gear. Lots of people like the front one because it's got the dial on it, but it does not have preload, so some of them are pretty loose, and you'll get backlash. You'll see lots of toroids in the receiver and the transmitter. I'll talk later about toroids. For the VFOs, all of the VFOs of my 21st century radio are 5 to 5.5 megahertz. I make a Colpitts oscillator with a lot of capacity in the tank circuit, with the cathode coming in between 2 big caps. Very, very stable. I don't know how stable an original Arc 5 VFO is, but probably not this stable. Receiver, there's the McCoy filter, pre-selector up here, exactly the same VFO. Got into the receiver and discovered I had to put shields everywhere because everything is so close together. People say, oh, if you use toroids, they won't couple and all that. Well, something was coupling, so I had to put some shields in there to tame everything down. Ended up using the front capacitor frame only so I could get the dial on the front. So that's all that does, and I stripped everything else out, and that gives me a nice place to put the RF amp and the mixer inside of a shielded box. So that's the output. Notice the ancient 141S, is it? I can't remember. But that's the output spectrum with 2 tones. So everything is about 10, 20, 30, almost 40 dB down. The IMD and the unwanted sideband and all of that. And that's on a scope, that's 40 watts PEP. So it's very, very clean SSB for a phasing rig. And then this was something I did just for fun. I was familiar with things like random vibration from my job, and so I thought, well, what the hell? Maybe white noise audio is kind of the same deal, and you run it through a filter and see what you get. So what I did is I took a FM radio and tuned it off the station so I got white noise. Took the microphone and just stuffed it right next to the speaker. Turned on, this time I've upgraded to a 141T now, and I looked at the output spectrum, and it is, by God, right on the money. These are 1 kilohertz, so 1, 2, 2.5. It's about 6 dB down, and there ain't nothing else going on. So it's a very, very clean output for a phasing type radio. So another radio I made was what I call the Cheap and Easy 2. Now I had a B&W phase shift network left over from when I was a kid. I bought it at Walter Ash Radio. I still had it, and I had a lot of junk transmitters. I think I ended up buying 8 or 10 of these things. So I had boxes full of capacitors and chassis and all that stuff. So I thought, I got this phase shift network. I kind of got everything I need to build one of these things. But no disrespect to Tony, but that design has a lot of shortcomings for a modern to use it in a modern environment. So I still used the 352 Q4 and the 1625s, but I put my coal pits oscillator in, and I added a separate dual triode mixer stage, because that always seemed marginal to me to take a 6V6 or a 12BY7 and mash 2 signals in it and think you could get 60 volts peak to peak out of it to drive those finals. I added ALC, just grid rectification, a meter, which the Tony's rig did not have, push to talk, and I stuffed an antenna relay in there and a TR relay. So if you look at the back end of it, it's like a Collins S line. Everything's there you need to hook up to your linear and your receiver and everything else. And I also added a spot function. And K5LYN is the lucky owner of that radio. We made a deal, and because he's the 20-meter vintage sideband net guy, I wanted him to have it so I could hear my own radio on the air. That's and this was the Navy transmitter, so it was black wrinkle. One thing I did that added that the original design did not have is a metal plate between the tubes and the front panel to kind of mount stuff on and give you some shielding, although you still got all these RF components around the tubes, so you still have to use shields on your tubes. Underneath, more toroids, the coal pits oscillator. On this radio, I just used octal tubes on the back end because I didn't feel like making a plate and putting miniature tubes in there. They were already punched for octal sockets, so I just used them, I think that's a 6AG7, that's a 6SN7 mixer, and the 12SK7 VFO. And the nice thing about this design is the mixer is right next to the VFO, so there's a little cap between those two. And I'll talk in a bit about how you get the signal up to the PA tubes. These transformers are a couple of dollars from Mauser. Their transistor transformers are like 20K to 1K. You just decouple them with some 10 mic electrolytic caps, and they work just fine. You got to get the DC off of them or they can saturate, but they work just fine. And if you design it right, the windings are at ground potential, so you don't have a lot of B+ on those tiny little transistor transformers that were only meant for 10 volts. You cannot hardly find the square Lionel, I guess, made those transformers anymore. After that, I had more junk, and I also found another 352 Q4 at a Hamfest. So I picked that up, and by that time, I had met Mark and U6X. So I said, hell, I'll make another clone of that one I just made. So that transmitter is virtually a clone of the previous design, except it's on 80 meters, not 20. And this is something I learned. There's a big range set capacitor in here for the ARC 5 original VFO. Take that out and throw it in a box, and now you got all this real estate here and all this volume, and you can stuff the mixer plate coil and the driver plate tank circuit into that area. And so you bring the wires up from underneath into the coil, and then you come out the other end and you go down to the 1625 PAs. So you avoid that trying to get around the tuning capacitor underneath. And as I said, that is now owned by NU6X. So pretty much the same thing. The previous coil was wound on 1-inch PVC pipe with genuine World War II silver-plated wire. This one is wound on a, what is that? That's a, I guess that's a VFO coil out of the 3 to 4 megahertz transmitter. So that's the 80-meter tank coil. Not much else different in this radio to speak of. I think, I did use a 12A6 here for the driver because it works fine on 80 meters. The underneath is almost identical. octal mania. In between doing the original vintage single sideband special and those two cheap and easies, I still wanted to make a 100-watt transmitter with 6146s, and now I decided, well, I'm just going to have to buy the sheet metal, you know. So I said, what can I do now? Well, I was at the Fort Tuttle Hamfest, and I picked up a whole bag of those snap ring sockets, octal sockets that they used to use in command transmitters. There must have been 50 of them in there. I thought, you know what? That might be fun to try to make a radio with all octal tubes to see if they can really perform as well, you know, as the miniatures. Because let's face it, all your octal tubes have a miniature equivalent. Electrically, they're the same. And, you know, at my age, it's nicer to work with octal tube sockets because they're big and you can see what you're doing. So the transmitter is here, sits on top of the receiver. Each one has 12 octal tubes, a pair of 6883s here because I'm running off a Heathkit 12-volt supply. The VFO signal from the receiver comes up into the bottom of the transmitter. So we're looking at about 4 or 5 inches of coax, so you don't lose a lot of signal that way. Enough room to put a built-in speaker. They band switch 80 and 20 only, and you get lower sideband on 80 and upper sideband on 20. There's no selectable sideband, but who cares? So they were done, and then they both use the INRAD 9 megahertz filter, so they're 2.1 kilohertz wide. It's a modern filter. You can get it for $130, I think. So each one has an INRAD filter. I do not couple the carrier oscillator to the BFO up here. I just zero beat them, and they're fine. They're shown on top of my HB600 linear, which is uses a pair of 572B. So I designed them so that everything would stack up and you get a 25-inch tower of hollow state homebrew SSB. So transmitter on the left, receiver on the right, 12 tubes. The advantage to metal tubes is, of course, they have a shield that comes out on pin 1. You just ground that, and now you got a shield. The advantage to glass tubes is they glow in the dark. So the VFOs are identical, and they've been flipped over so you can get the tuning knob up higher. Here I did keep the range set capacitor, and there is a metal plate that goes across on the receiver here because the foot, the mounting, the plastic foot on the bottom can flex this and cause VFO warble, so that takes care of that. Just a few shields in the receiver there. I don't think there's anything else. Oh, all the IF cans are out of Arc 5 receivers. That's the inside of the PA cage. Again, I use 6883s. Built-in antenna relay. To mount the radios together, that's 1-inch angle stock, 1/4-inch bolts. And then there's a little 1-inch bar stock back here in the back end. That makes a very, very cheap and sturdy way to mount those two radios together. And it displays everything very well. You can see them. And I don't care if RF goes all over the place. This cage and that cage, I had to put around the 6SN7, 12SN7 carrier oscillator to keep it from radiating, because one of the problems I found at 9 megahertz is you got to keep that 9 megahertz out of the IF strip. You don't want it going into the front end and turning on the AGC and reducing your gain. HB600 linear, I decided it was time to homebrew a linear. I had collected the parts, and I had an SB200, so I basically just tried to clone it. So it's they're not 872Bs, they're 572Bs. Grounded grid, about 600 watts. And the cabinet was deliberately designed with a little recess so that you can set the other radios right on top. So let's see. Transformer. I got that from surplus sales in Nebraska. Beautiful new old stock military transformer. 920 volts AC at 700 milliamps, so it doubles up in a capacitor input to about 2700 volts. Nice transformer. Unfortunately, they don't have any more. I wanted to buy one for a later project, and they're all out of stock. This is the high voltage doubler board. It's just homemade on fiberglass board, drilled out and point-to-point wired on the bottom. So it's got the diodes and the equalizer, bleeder resistors, and everything on it. The tubes, there's a fan that blows directly on the tubes. The band switch is a Radio Switch Corporation, very, very heavy duty unit. The coil, the PA coil, that was a lot of experimentation. That's out of an old TU5 tuning unit. So trying to find the optimum, windings and taps and things, because every time you mess with one, it screws up the other one. So back and forth. It does have tuned input, a Pi network input, just like the SB200. So the coils are wound on national XR50 forms. And that was a project trying to get that all squared away. That's where I used my Drake TR5. I just drove the input of this thing with the TR5 through an SWR bridge, and then you just fool around with the caps and inductances till you get no reflected power. Filament choke is a $10 kit from Amazon. You can still buy it. You just wind it and then you put some shrink fit over it. Probably not much else. I have a 3-second soft start in the high voltage power supply. Pretty standard. Charge up a capacitor, then a relay closes and finishes the job and puts full power onto the transformer. Same circuits used in the linear back in the corner. And by the way, all those radios are back in the corner where Mark is. The ones that I brought. Okay, this is the octal tri-bander transceiver, my most complex radio to date. It's right back there. Some of you have seen it and heard it. It's basically the Octalmania radios that I combined into a transceiver. But I also wanted to add 40 meters to it because, you get 80 and 20 free with a 5 megahertz VFO and a 9 megahertz filter. But for 40 meters, you got to inject something else. So I developed a new buffer and premixer circuit that would give me 16 to 16.5 megahertz injection for 40 meters. Single band switch right in the middle. It's arranged so that all the receiver stuff is on this side and all the transmitter stuff is on that side. I had to build a matching power supply speaker unit. There's two 4-inch speakers because to save my life I couldn't find a 6x9 speaker anywhere. And I had two 4-inch speakers, so I just hooked them in series and there they are. Looks a little weird, but it's not stereo. Let's see. You'll recognize that as a precision pot dial mechanism. I use that to turn the rotary inductor that's in the PA. So, homebrewing. This is before I started wiring anything. It took weeks to do the sheet metal work and lay it all out. I put a lot of thought into where to put stuff to try to keep RF leads as short as possible. It turns out that with the receiver stuff here and the transmitter stuff here, a lot of wires kind of cross in the center of the radio. And in fact, that's where the mixer is that's used for both receiver and transmitter premixing. A lot of work went into the band switching mechanisms. There's 7 ceramic wafers, 16 poles of band switching total. And there's a shaft that runs right down the center with a flexible coupling here and somewhere in here. So that's what it looks like before it's wired. It kind of looks like a Heath kit, doesn't it? Ready to go. That's the top view of the completed radio. We'll look inside that in a minute. Unlike most commercial transceivers, this one does not share the tuned circuits between the receiver and transmitter. Most rigs, KWM2, SB100, they run the receiver RF through the Pi net and then down and through the mixer, and I thought that just looks like too complicated for me. So I just made separate front ends, mixer and driver tuning and receiver RF amplifier tuning there. They're totally separate. Mark always comments that, look, he even labels the tube sockets, which they are. That's the underside. So I hope later today I can take this radio apart, take the top and bottom off so you can see it close up, because it really is something to appreciate. Yes, it's all blue wire. It's all Teflon wire, and Teflon wire is very expensive, but I scored about a 400-foot roll of it for $13 or something a while ago, and I thought I'm just going to use all blue wire because, who's ever going to trace it out anyway? Who cares? VFO components down here, again, it's mounted upside down so you can get to the knob. I'll talk about these trimmers and the IF cans in a minute. That's the old ARC5 receiver output transformer, which is used to drive the 4-ring diode balance modulator. So this is transmitter, speech amplifier, carrier oscillator, balance modulator, and that's the 21.5 megahertz oscillator. These are all receiver circuits, AGC, common IF between the receiver and transmitter, second IF, product detector, audio, voltage regulator. And then all the band switch circuits are up here. RF receiver, RF amp, receiver mixer, pre-mixer buffer for both receive and transmit, transmitter mixer, transmitter driver. Notice the piece of aluminum coming around here held in with screws. That's so I can run the bottom, that's 1/8-inch aluminum, so I can run the screws that hold the bottom into threads, because I hate sheet metal screws. You only get so many installations and removals, and then you got a big problem. So I did that on all of these radios. I just countersunk some number 4 screws in there and bolted that on there. That's the final block diagram. That's also available on the website. It's pretty simple, actually. The receiver is RF amp mixer. Goes into the filter through a little tiny signal relay with gold alloy contacts that's made for switching dry circuits. Common IF amplifier, receiver IF, product detector, audio. Receiver mic comes in here to a 6SL7. There's a tone oscillator for tune-up. Goes into a half of a 6SN7 audio driver. 6J5 carrier oscillator. That goes into the balance modulator. And then that comes up and gets switched into the filter on transmit. Goes through the common IF amplifier, down to the transmitter mixer, driver, and into the PA tubes. VFO is here, 21.5 megahertz oscillator here that's only turned on 40 meters. Goes into a 6AC7 premixer whose output is either 5 to 5.5 or 16 to 16.5. It's a lot like a Drake TR4 or the Hallicrafters SX146 HT46 combo. I've always liked 813s. As I mentioned in the article for electric radio, if there was ever a beauty contest for tubes, the 813 should be a finalist. Nice big bottle, you know. After I built the octal tri-bander, I always wanted to build an 813 linear, so I did. And it turns out you can get 813 tubes a lot cheaper than 572Bs now, and they're a much more rugged tube. Pair of them in grounded grid. A lot of the design is identical to the HB600. Why reinvent the wheel at my age? New old stock triplet meters, so I can measure plate current, grid current, and plate voltage. And on a grounded grid linear, you should really be looking at the grid current at the same time as the plate current, because if your loading is too light, you're going to really draw a lot of grid current. It's 80-40-20, just like the 86 or the HB600 with the 572Bs. Top view, you will note the Antec toroid transformer, because I could no longer get the nice one from Fair Radio Sales. And I thought it's about time I tried to do this, because if anybody wants to build a linear, you can buy that transformer for $105 and it fits in a standard USPS shipper. So for about an extra $12 you can have that transformer. There's the tubes, dual section for the plate tuning, and both of them are used on 80 meters, and only the rear one is used on 40 and 20. Selected by again, a radio switch, band switch here. There's the same exact doubler board. It's just laid down flat on this radio. National R175A plate choke, just like the other linear. Two brand new 1000 PF 5 kilovolt doorknobs. This was a Illumitronics 2408 D4 that I pruned down to the 3 bands. I used braided wiring to connect the RF circuits. Now, you can say what you want about skin effect and all of that, but my thinking was, if I use stiff wire and I start grabbing this chassis and moving it around, because chassis they're flimsy as hell, I'm going to break something. I'm going to break a tube, I'm going to break that choke, or I'm going to break something off the capacitor. So I put flexible braided wire to connect up the RF stuff so that it can flex a little bit and not break, and it works fine. I didn't do that on the previous linear. There's the bottom end of it. Same as before, the $10 Amidon choke. Same exact coils, because I found out that a 813 in ground to grid looks an awful lot like a 572B. They're practically interchangeable. In fact, I used exactly the same coils, and I only had to change the Pi network capacitors by about 20 PF to get it to work right. Now, something I did learn is when you're working with these tubes, you want the amplifier to be right side up or upside down. You don't want it to be on its side, because filaments droop and they short out. So all the work to develop this and get this tuned up was done with it flipped upside down, and again using the Drake TR5 to get to drive it, because it's easy. It's broadband. You just turn the mic gain up and you got some RF. By the way, I also used the TR5 to do a rough cut on the coil taps using the cold tuning method. You guys know what that is? So you take some load resistors and you run them from the plate circuit to ground. In this case, I used 10 270 ohm 2-watt resistors. And you feed the RF into the side there, and you just play with the plate circuit until you get minimum reflected power, because the Pi network will work both ways. And you end up with several hundred volts, of course, in the plate circuit end. But it gives you a good rough cut, a place to start. That toroid is only mounted with a single bolt, so underneath I have a piece of angle stock running all the way across the chassis, because these chassis are at best they're 060 and they're soft aluminum and they're pretty flimsy. And this is a right angle shield that I cut out of an old TU5 tuning box, because I wanted to make a strong foundation for that toroid. And then this is a plate of tempered aluminum, 062, but it's tempered, and it's held in each corner with a 632 screw. So with all that stuff together, that toroid stays put. Oh, and I also used 2 5-volt at 10 amp control transformers in series, because they were on sale at MPJA. They don't have them anymore, but you can get a 10-volt 10 amp transformer from Hammond. So that's the radios that I built. Now, how do I start a new project? Well, for me, it's always been about scoring some rare part at a ham fest. I'll see a mechanical filter or a crystal filter or a big power transformer, a rotary inductor, audio phase shift network. So then I look at those parts and go, I got a pretty good idea of my inventory of junk at home, so I think, what can I make? So I start developing a vision of what it could look like when it's done, even what the front panel is going to look like and circuits I'm going to use. Then I look at my junk to see what I might need, and then I make want list, and what can I pick up at Hamfest, eBay is a kind of a last resort, or a new purchase like for electrolytics and things like that you can still get. So that's just how it starts. I don't know, everybody's probably got some rare piece of junk out there that they thought they could make something out of, so that's how I do it. That's how the Cheap and Easy's got built, because I had the phase shift networks and I had all the other junk. So. And you can make these radios, you can find these parts, they're out there. Now, how do I wire? Well, believe it or not, I wired that whole octal tri-bander transceiver from that block diagram that I drew out in pencil. So I did not draw schematics ahead of time. I did not design circuits ahead of time. I just kind of grabbed circuits from ARRL or W6SAI, or what was it, Bill Orr, whatever his call is, his handbook, and commercial radio manuals. And then I just wired it up and got it working. Now, if it was a really, really complicated circuit, I might draw out a rough schematic. So, if it was going to be hard to trace later, I would draw the schematic. So, I have done some breadboarding. It isn't hard to do. You just get an old junk chassis, and you'll notice the Heathkit lab supply up there for filament and plate voltage, and grid or C- if you need it. But this was the breadboard that I used for the premixer buffer circuit. So I wanted to get the thing working right before I stuffed it into that band switch section where I couldn't get to anything anymore. So I did that, got it all working. I think you can see, I don't know how well you can see, but you can see traces on the spec and on the scope there to get it all working. So it would cover the band pass and give me a nice shape. I'm not a band pass filter designer, with triple integrals and all that stuff. I just figured some rough inductances for the coils and just coupled them with 1, 2, or 3 PF caps and trimmers to resonate them and resistors to make them a little flatter, and that was it. So laying it out, this is the linear under construction. The main idea here is the first thing you want to do is make sure your RF paths are short, so you don't have to deal with trying to couple circuits over long distances. Then I started thinking about the front panel. I want it to look nice. I want it to be functional, pleasing in appearance, and to make sure there's no interferences, because the last thing you want is to drill holes in the chassis, then put the panel on and find out something doesn't fit. So you put it all together, and then you start moving stuff around, and then you want to make sure you can remove and replace parts. You don't want to, if you can help it, you don't want to bury something in there, particularly if it's a high-risk circuit, and you might have to go in and fool around with it. The metal work. Okay, on this page and the next page, you will see all the tools that I use to do the sheet metal work. An old Craftsman 8-inch bench drill press, a belt sander, which I really only ended up using for the fiberglass boards and pegs. Black & Decker Workmate to hold stuff down. I don't have a brake press or shears. Just don't got it. I've never even taken a high school shop course, so everything I did I learned by trial and error the hard way. They're not. I will claim that that's the fastest way to do stuff. If you got the right tools, you could probably knock out this sheet metal work pretty darn quickly. But not having a brake press to bend metal, I had to make all my shields using angle stock, and then I riveted the pieces of angle stock on there to give me a right angle. And I used a lot of machine screws into threaded and tapped holes. Whenever I cut any kind of angle or sheet, I always cut it a little bit big, because you can always file it down, but you can't put back what you didn't mean to cut off. Get a little water here. So I cut it a little bit oversized, and then I cleaned it up and squared it up with files. God, a lot of filing. So here's the rest of the tools. Now you won't see anything there that's not pretty common, all cheap. All sheet metal and angle iron or angle stock was cut with a Sears saber saw and Bosch metal cutting blades, pop rivet gun, various squares, hacksaw, rechargeable drill, corded drill, bunch of chassis punches, and a micrometer. Those are cheap, and that's essential. Automatic punch, Harbor Freight thing for like $3. You push it down, it goes pop and makes a dent, so you can drill a pilot hole. Harbor Freight scribe for drawing lines on metal. Nibbling tool, deburring tools. I did have 4, broke one. And tons of files of various sizes. High quality files is something you should have. Chassis punches I did collect off of eBay and Hamfest, and like I said, you don't have to have a chassis punch if you want to spend an extra couple of days filing out a 2 1/4 inch hole for a meter, and it might be round when you're done. So that was worth the money. And I cut all the the socket holes in no time at all with a punch. So this was the 813 linear cabinet being made. So it's 1-inch aluminum angle stock. There are little joiner pieces in the corners to join these 3 pieces together. And I just drill and tap 832 threads into the joiner piece, and then counter bore it, and then put a flathead screw in there, and then that allows me to put a cover on there that's flush with the aluminum. So all 3 cabinets on those radios were made exactly the same way. Took several weeks, but sheet metal work is not my favorite thing to do because it tends to get very repetitive and messy. But if you're going to make a vacuum tube radio, you got to do sheet metal work. More of the metal work. This was the 80 meter cheap and easy being built up. So for the Arc 5 chassis, I totally strip them, and then I clean them with 409, and then I go in and I start mounting parts. Again, it looks like a Heath kit, right? Don't put the tuning capacitor in till the very end because it gets in the way of everything, but you keep fitting it to make sure you haven't created an obstruction. And I made a new front panel for it because almost every command set you get is going to be a wreck. I mean, let me just say that I have never destroyed a pristine command set. All of them I ever cut up and junked, they were junk, and I never paid more than $10 for any one of them. So if they were really worth something, they would have been more than $10, right? So I made a new front panel, and it's held on with sheet metal screws around here. And that particular radio was a signal core radio, so it was natural aluminum. So there's the thing being built up. I was wiring up the sideband generator circuitry up here. I always use Teflon wire because in any radio where you're going to be doing a lot of experimenting and screwing around and unsoldering wires, PVC wire just burns up and looks like hell. So Teflon wire, you got to find it, but I always use it. Silver coated stranded Teflon wire, and I always tin it before I strip it and tin it so it doesn't just flay all apart when you go to connect it. And then I don't zip tie anything until I'm done. But I leave enough room in all my wires. I try to visualize what the harness would look like when it's done, and then you can fish zip ties in underneath the harness with forceps or what do you call them, hemostats, and pull them up, and you can get it done. And I have to stop every once in a while and clean everything up because after a while you can't find anything because there's so much junk on the bench. So at a major phase, I usually clean everything up. Element testing. Here is the same transmitter. This is the sideband generator circuit. I haven't wired anything else up back here because I wanted to make sure all of this worked before I went any farther. Tubes and toroids. Okay, I use, this shows the toroids used in my vintage SSB special. So there's toroids all over the place, and they are resonated with, in this case, ceramic trimmers. Really nice, eerie trimmers. I use them all over the place, and they work just fine with my tube circuits. The reason I do that is when I go to build one of these projects, I look at my slug-tuned coils. No two are alike. I don't know anything about them. I don't know, is that slug 1 to 20 megahertz, 20 to 50 megahertz? Is it a green one, a red one? Hell, I don't know what it is. And none of them look alike. So I kind of like my radios to look like the guy at least bought the same kind of coils all the way through. And you can't find them today. Mark knows. You can hardly find slug-tuned coils with known characteristics at a decent price and enough quantity to do something. I mean, there's probably, I don't know, 10 of them in this radio. So I used toroids, T50-2, I get them from Amazon, they're 65 cents a piece, big deal. And using the published formulas that are out there everywhere, I can get within 10% of the planned inductance just by winding them to the formula. Minor annoyances, you got to mount the stupid thing somehow. You can't just leave it dangling with wires. And you need a variable capacitor to resonate them in a tuned circuit. So those are things you got to do. So you got to come up with a way to mount them and resonate them. Now this is one method I've used. I make what I call a little toroid module, a little tiny piece of perf board. This is the toroid wound up. These are extra components I'm going to mount on the board when I'm done, just so I don't have to run off and do a bunch of tie points and stuff. Make little hooks out of 18 gauge plated copper wire, and you could push those little hooks into the perf board, solder to the bottom of them, and then they make a little hoop that you can connect your external circuits to. There's a aluminum spacer here, 632, ground lug to ground the bypass caps to it. There's a little tiny piece of threaded rod that runs through here and then comes out the top, and then I screw a little piece of 1/4-inch plastic tubing on there. That just gives me something to center the toroid up on. And then I dribble epoxy all over it when I'm done. Now, I have read that, oh God, you shouldn't use epoxy. The dielectric constant's too great, and you're going to increase the distributed capacitance of the windings and blah, 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 blah. Every time I've ever done that, and I went back to repeat the circuit, with the variable capacitor, it was right on. It didn't make any difference at all. So maybe the frequency isn't high enough where it really makes any difference. So here's a balanced modulator board and one of the cheap and easy. So there's 3 toroids on there. That happens to be the balanced modulator output coil, and then it couples into the IF amplifier. So those are some ways you can do toroids. You can mount them to a little piece of perf board with a spacer. Or you can tear apart an old ARC-5 receiver and get all the coil cans out of it. And most of them, the IF transformers, have little variable capacitors in the top. So this particular coil is a mixer coil from the Octalmania. So it's 20 meters and 80 meters, and the 2 capacitors tune the 2 different frequencies. And I put sockets on the bottom of some of these coils because I thought I was going to be unplugging them and rewinding them and all that, and it turned out to be a waste of time because the toroids came out right where they were supposed to be. So I could have just left them alone and mounted them the way they were. This coil, I think, was out of the front end of an ARC-5 receiver, and this is an IF transformer. So that's another way to do it. That's just a paper tube, and then epoxied in the bottom, and you slide the toroid over it and glue it down. For the octal tribander, I did it this way. These IF cans and all of the trimmers I used came out of an old airborne transceiver. I don't know which one it was. It was probably Collins. And you're going to hate me, but it was a brand new spare wrapped up in cheesecloth. Brand new. All the tubes in it and everything. Had, 10 tubes in it or something. But I bought it for $4 like 35 years ago, and it's been sitting on the shelf. I said, I'm going to just tear it all apart and use those IF cans. Because that's a problem when you're trying to homebrew, is what do I use for an IF can, How do I make an IF transformer? So all the innards here also came from that transceiver. So this is a fiberglass peg that a toroid's going to be pushed over and glued to. That's the original trimmer. And this is the bottom, and I drilled holes in here and pushed these little Teflon standoffs in there, and I can wire up things like bypass caps and decoupling resistors inside the can. It just cuts down on how much garbage you got to try to wire up somewhere else. This is the band switch section, so that's one of the band switch sections out of that transceiver back there. The plan all along was to make them removable. So there's only 3 wires that have to be spot tacked on, here, and a ground wire. You can slide the shaft out, take the screws out of the sides, and slide it out if you need to work on it. So they're all made that way. And of course, in order to wire everything under the band switch, you need all of these removed so you can get to it. When you got that all done, then you can put the band switch sections in. Well, I've got a little bit more than a VTVM with a RF probe. So nowadays, this is my test equipment. Nothing too fancy. For a transmitter, you really should have a wideband scope and a two-tone oscillator and a spectrum analyzer. And for a receiver, you need a really good signal generator. Heathkit Labs power supply is nice for breadboarding. How did I do the chassis labels? They're all water slide decals made from Papilio stock. There's directions on my website on the process. But all the labels were custom designed using Microsoft Visio software. I'll get into what it was flat gray, then I put the decals on, let them dry, baked the whole thing in an oven, the panel, and then sprayed it with clear matte. They come out really nice, as you can see. That's the stock 10 sheets for about $15. It's dirt cheap. You can print it on a laser printer. They also make inkjet, but you have to spray an inkjet decal with Krylon, otherwise the water will dissolve the ink. So with laser, no problem. You can only do black and white if you have a cheap laser, but if you have color laser, you can do color too.
Is that Papilio?
What's that?
What's it called? The stock called?
It's Papilio.com. Papilio. They're in Texas. They got all kinds of decal stuff. This shows the decals printed and being cut out, and I put a black border around all of my stuff so I have something to cut up to. Also makes the transition smoother so you don't see it, and it also gives you a vertical or a horizontal line to line the thing up on. And I have bullseyes to line them up over the shaft. That's the overall process. I'm not going to go through the whole thing. You can read it, but custom meter scales, also designed on Visio and printed out on plain white paper. I disassembled the meters, figured out how to pop them apart, designed the scales. Everything lines up on the two mounting screws, painted the metal underlay white, lined it up, and glued them together. And when you're putting a meter together, you got to make sure you don't have any FOD in it. Yeah. So during a build-up, I just do rough documentation, and like I said, I draw a schematic if it's like a control circuit or something with wires going everywhere. When it's completed and I know there's not going to be any more changes, then I go in and I draw up the final schematics in Visio. And once I did that the very first time for my first radio, I had my little library of symbols and I just used them over and over again. And the way I did it, a resistor looks like a resistor instead of a rectangle. I hate that, like 21R2. What does that mean, Next page is a typical schematic. That's the way it came out for the dual 813 linear. So, and I try to make my schematics so they're somewhat easy to follow. So that's the way it came out. Anybody got any questions? Questions?
Is that on your website?
It is on my website, kgtr.com.
What was that punch sheet aluminum? Did you buy that?
That is called perforated aluminum sheet. You can get it on Amazon, but I would recommend going to Granger. It's the same price, and they won't screw it up like Amazon did to me twice. But it's a 36 by 40 inch sheet, and you could get it in 050, 062. I use 062 almost everywhere.
Where do you get the band switch in the wafers?
Junk box, Hamfest acquisitions. Those radio switches I used in a linear I got somewhere years ago. Were real cheap. And all the rest of them, I just kind of, whenever I see rotary switches in a junk box, I buy them. So, you can't buy rotary switches anymore that I know of. And you sure as hell can't find shorting switches because I've looked and nobody sells, they're really hard to find. I hope to open that up later so you guys can look inside. We'll see how that works out. Okay.